Hi, I'm George, and in this video I'll be presenting you the best idea of the Fluffy Tech team. Our best idea is called FLAMP, and that comes from Fireball Lidar Action Mapping Probe. Throughout the whole work that we've been putting in for this course, we tried following the idea that stems from this quote, which says that our entire universe is probably in a tiny glass jar somewhere, placed on a shelf in an alien child's room as a science fair project that got a C-. So as we can see, our whole world is far from being perfect. So instead of just striving for perfection from the very beginning, we tried instead to build upon our best idea and develop it until it eventually became probably the best C- idea ever designed. Our team members are George, the idea man, Ryan, the thinker, Tatiana, the documenter, and Shiva, the handyman. The overall challenge for our Epic Challenge course was the emergency challenge, meaning that we had to develop a system that enables astronauts on Mars and experts on Earth to come up with a solution to an unexpected severe technical challenge and implement it correctly on time. Our challenge refers to the report producing subproblem. So the situation is that an accident has just happened at the Mars base outside the habitat, and our solution would have to produce an initial report of accident area with a 5 mm by 5 mm by 5 mm and 1 degree Celsius map resolution that then would be sent to experts on Earth. Our best idea for this subproblem is FLAMP, which firstly has a LiDAR projectile part which would be launched in the air for initial in-depth mapping of the accident area, and then secondly, the ball rover part of FLAMP, based on the initial mapping done by the LiDAR, would proceed into the accident zone and do the high-resolution topological plus thermal mapping. In order to test our best idea, mainly its robustness, we came up with 3 different experiments which we also implemented. The first experiment regarded how tolerant is the ball rover part of FLAMP against Martian terrain irregularities, and in order to do this we simulated a small portion of Martian terrain with bumps of different height and width, and we drove a small RC car around those bumps in order to see how would the rover part of FLAMP deal with these bumps. And after the experiment, we concluded that some bumps would be too big for the rover to just tackle. The second experiment we did referred to the consistency of the FLAMP LiDAR module measurements in dust storms, and in order to test this, we used a laser distance module, which we used to take some measurements after we poured sand in front of it, and we concluded that the LiDAR would not be enough to produce the in-depth mapping if a sandstorm were to occur. The third and final experiment referred at how tolerant is FLAMP of the wind inside Martian dust storms. And in order to do this, we used some very powerful server rack fans, and we drove a small RC car in front of these fans in order to see if the powerful wind would throw the rover part of FLAMP off the track. Our whole work for this course has been split over 8 weeks, and these are the main milestones that we covered. As future work, if we were to further develop our FLAMP idea, we would firstly proceed to designing and conducting some more experiments in order to test the viability of our idea, and if the majority of those experiments would be successful, we would also try and build a small prototype of it. This has been George from the Fluffy Tech team. We hoped that you enjoyed our idea, and we also thank you for the opportunity of having us work on this course. And yeah, see you on Mars.